Welcome to GE Critical Power's Power Talks. Today we are going to talk about savings through power system efficiency improvements. We'll look at how the technology of power conversion has changed and how this has affected the way that power supplies perform. Changes have enabled higher efficiency, which reduces the amount of energy consumed both directly and through reduction in the cooling required. Lower operating temperatures also have a direct effect on equipment reliability and failure rates. When we look at changes in power conversion technology over the last 40 to 50 years, we can see that the changes are dramatic. Size reduction, volume reduction, density improvements, weight reduction, and efficiency improvements. Focusing on the efficiency changes, efficiency of the 1970s era technology was typically in the 80 to 88% range at best, while today's technology regularly yields efficiencies of 96 or 97%, an improvement of 17 percentage points. If we look at the flip side of efficiency and consider heat release, our 80% efficient rectifier wasted 20% of the utility power as heat. Today's rectifiers may only waste 3% of the utility power, a staggering reduction in heat release of 85%. The peak efficiency numbers compared in the previous page are not the complete story, however. If we look at the way efficiency varies at different load levels, we can see that the newer, high-efficiency rectifiers operate at higher efficiencies over a much broader operating range. This is particularly important at low utilization, where the capacity of the power system is much higher than what is strictly needed by the loads. This chart compares the heat release numbers for various rectifiers, showing the improved performance that can be achieved with various upgrades. The rows highlighted in red text compare one of the older ferroresonant rectifiers with one of the latest high-efficiency switch mode units. The ferro produces almost 1,000 watts of heat per 100 amps of output at full power, where it is most efficient. The SMR produces less than 200 watts per 100 amps of output, a reduction of almost 80% in the heat release. We have seen that the newer technologies have resulted in significant reductions in size, weight, and volume of power conversion equipment, but more importantly, improvements in efficiency. This results in reduced operating expenses from direct power usage in the utility bill, plus reductions in the facility cooling costs. Since the failure rate of electronic equipment is directly proportional to the temperature of operation, it can be expected that cooler operation will also result in longer mean time between failures and greater reliability. Thanks for watching this Power Talk. I hope it's been informative. If you'd like to know more about GE's DC power products and systems, please contact your local GE representative or contact us through our website